Good morning everyone. I am Sk.Nikhat Anjum of CSE-D. Today I am here to explain about Einstein's coefficients. Let N1 and N2 be the number of atoms per unit volume of energy levels E1 and E2 respectively. Let N be the number of photons per unit volume at frequency nu. Then rho of nu will be the energy density of interacting photons and is given by rho of nu equals to nh nu. When these photons interact with atoms, both upward, that is stimulated absorption, and downward, that is spontaneous emission and stimulated emission, takes place. Let us see in detail about stimulated absorption, spontaneous emission, and stimulated emission. Stimulated absorption. Let us consider two energy levels with energies E1 and E2, where E1 is ground state and E2 is excited state. Usually atoms are present in ground state E1. When a photon of energy h nu is incident on the atom lying in ground state, then it excites to higher energy state E2. This phenomena is known as stimulated absorption, or the transition of the particle from lower energy level to higher energy level with the help of external source is known as stimulated absorption. So, the rate of stimulated absorption depends upon the number of atoms per unit volume N1 and interacting energy density rho of nu. It can be written as rate of stimulated absorption is directly proportional to N1 rho of nu. Removing the proportionality symbol, we get a proportionality constant, that is B12. So, rate of stimulated absorption is equals to B12 N1 rho of nu. Let it be equation 1, where B12 is called Einstein's coefficient for stimulated absorption. Spontaneous emission. Let us consider two energy levels with energies E1 and E2, where E1 is ground state and E2 is excited state. Usually atoms are present in ground state E1. Let us assume that the atom is in the excited state E2. After lifetime, the atom de-excites to its ground state spontaneously by emitting a photon of energy h nu. This phenomena is known as spontaneous emission, or the transition of particle from higher energy level to lower energy level without the external source is known as spontaneous emission. So the rate of spontaneous emission depends upon the number of atoms per unit volume, N2. It can be written as rate of spontaneous emission is directly proportional to N2. Removing the proportionality symbol, we get a proportionality constant A21. So, the rate of spontaneous emission is equal to A21N2. Let it be equation 2, where A21 is called Einstein's coefficient for spontaneous emission. Stimulated emission. Let us assume that the atom is in excited state, that is metastable state E2. The transition of atoms from higher energy state E2 to lower energy state E1 with the help of external agent, that is spontaneous emitted photon, is known as stimulated emission. Here, the direction of propagation, phase, and energy of emitted photon is exactly same as that of interacting photon. So, the rate of stimulated emission depends upon the number of atoms per unit volume N2 and interacting energy density rho of nu. It can be written as rate of stimulated emission is directly proportional to N2 and rho of nu. Removing the proportionality symbol, we get a proportionality constant, that is B21. So, rate of stimulated emission is equals to B21 N1 rho of nu. Let it be equation 3, where B21 is called Einstein's coefficient for stimulated emission. Let us see the relationship between different Einstein's coefficients. At equilibrium condition, both upward, that is stimulated absorption, and downward, that is spontaneous emission and stimulated emission, transitions are equal. So we know that the rate of stimulated absorption is B12 N1 rho of nu, and the spontaneous emission rate is A21 N2, and the rate of stimulated emission is B21 N1 rho of nu. So B12 N1 rho of nu equal to A21 N2 plus B21 N1 rho of nu. Now transferring B21 N1 rho of nu to LHS, we get B12 N1 rho of nu minus B21 N1 rho of nu equals to A21 N2. Now taking rho of nu, that is energy density, in common, we get B12 N1 minus B21 N1 of rho of nu, that is equals to A21 N2. Now sending the part before the rho of nu to the denominator, we get rho of nu equals to A21 N2 by B12 N1 minus B21 N2. Now taking in common B21 N2 in the denominator part, we get rho of nu equals to A21 N2 by B21 N2 of B12 N1 by B21 N2 minus 1. Cancelling N2 from numerator and denominator, we get rho of nu equals to A21 by B21 whole divided by B12 N1 by B21 N2 minus 1. Let it be equation 4. As we have studied in the earlier classes about Boltzmann equation, so according to the Boltzmann equation, Ni equals to N naught exponential of minus Ei by kBT, where Ni is the number of atoms at ith energy level and N0 is the number of atoms in ground level, Ei is the energy of ith level, Kb is the Boltzmann constant, and T is the absolute temperature. Placing I by 1 in the Boltzmann equation, we get N1 equals to N0 into exponential of minus E1 by kBT. Similarly, replacing I by 2 in Boltzmann equation, we get N2 equals to N0 exponential of minus E2 by kBT. The ratio of N1 and N2 is given by N1 by N2 equals to N0 by N0 exponential of minus E1 by kBT whole divided by N0 exponential of minus E2 by kBT. Now cancelling N0 from both numerator and denominator, we get N1 by N2 equals to exponential of E2 minus E1 by kBT. As we have studied in earlier classes, we know that change in energy delta E equals to E2 minus E1 equals to h nu. So replacing E2 minus E1 by h nu, we get N1 by N2 equals to exponential of h nu by kBT. Let it be equation 5. Substitute equation 5 in equation 4. We get the equation 6 as shown. According to Planck's radiation law, energy density of interacting photons is given by rho of nu equal to 8 pi h nu cube by c cube whole divided by exponential of h nu by kBT minus 1. Let it be equation 7. Comparing equation 6 and 7, we get A21 by B21 equals to 8 pi h nu cube by C3. Let it be equation 8, and B12 by B21 equals to 1. Let it be equation 9. above equations 8 and 9 represents the relations between Einstein's coefficients B12, B21, A21. It is known that from equation 8, 8, pi, h and c cube are constants. So the ratio of Einstein's coefficient of spontaneous emission to Einstein's coefficient of stimulated emission is proportional to the cube of frequency. Similarly, from equation 8, the rate of probability of stimulated emission is equal to the rate of probability of stimulated absorption when in equilibrium. Let us discuss about the conclusions obtained from Einstein's coefficients. 1. Comparing stimulated emission with stimulated absorption. We know that stimulated emission is equals to B21 N2 rho of mu from equation 3 and stimulated absorption equals to B12 N1 rho of mu from equation 1. From numerator and denominator, both rho of nu, that is energy density, gets cancelled, and from equation 9 we know that the rate of probability of stimulated emission is equal to the rate of probability of stimulated absorption since they are in equilibrium. So the ratio of stimulated emission to stimulated absorption is given by N2 by N1. In order to have more stimulated emission compared to stimulated absorption, N2 must be greater than N1, that is N2 is greater than N1. Now the second one, comparing stimulated emission with spontaneous emission. We know that stimulated emission is equals to B21 N2 rho of nu from equation 3 and spontaneous emission equals to A21 N2 from equation 2. Cancelling N2 from both numerator and denominator, we obtain the ratio of stimulated emission to spontaneous emission as B21 rho of nu by A21. In order to have more stimulated emission compared to spontaneous emission, the photon density must be high. So these are the conclusions and about Einstein coefficients. Thank you.